All right. How'd the worksheet go?
Pretty good.
9 was something.
9 was whack. You got
3, 5, 9. On 3, 5, 9. All right, we'll go through one by one. Any questions on 1? 3. 2 over pi, was that right? Dropping a 2 over. Now here's the deal. You can take care of some of the sign issues if it's worded in a specific way. I forget how that one's worded, but if it said at what rate is the, what was dropping in this situation? I don't have a picture. Water level. Dropping, then 2 over pi would be appropriate because it's already taken care of the direction with the word dropping. But if it says, what is the rate of change of the water level, then the rate of change is negative 2 over pi centimeters per second. Make sense? Good talk. All right, 5. Surface area is shrinking by 4 square centimeters per minute, or negative 4 square centimeters per minute is the rate of change. How do you do on that one? Go right on that one. A little tricky? Would you like to see it? And now you guys quiet down, huh? Now that we're doing calc, everybody clams up. Ask away if you have a question. You need to just think. Do you want time to check it? Are they doing The Little Mermaid again? No, they never did that. They're doing Beauty and the Beast? Questions? Number 5. All right. Number 9. Dom.
We walked through number
9. Yeah. Go ahead and check it first. See if you can kind of piece it together based on the work. Little Mermaid's a classic. Was drawing the picture for that one challenging? Yeah, I can see that. All right, Dom, still have a question? Remember?
Yeah.
What are it?
I didn't even start off, right? So I just want to see what you thought at the beginning.
Yeah, so the question is, how do you, like, what equation is going to be appropriate to relate the variables in play, right? So as we read it, a man 6 feet tall walks at a rate of 5 feet per second towards a street light. watched that movie last night. Deathly Hallows. It's a good one. Harry Potter?
Oh.
You don't know Harry Potter?
I've never watched any of them.
Get out.
Alright, I'll do it.
All right. Walking towards a street light. All right, street light is 16 feet above the ground. At what rate is the tip of the shadow moving? All right. Now, here's the challenging thing. Do you agree that there's the distance that the man is from the light post's base, there's the length of the man's shadow, and then there's the distance from the base of the light post out to the edge of the man's shadow, right? There's a lot of things going on here. And so, did anyone try the Pythagorean theorem setup? Is that what you tried?
Yeah.
I could understand how you would think that, okay? And so, here's my answer to someone saying, how am I supposed to know what to use to set it up? And the frustrating thing, and the answer to a lot of math problems in life that we deal with are experience, right? So how do you know to use that? Well, once I show you, I bet you'll be like, oh yeah, I can see that. That's probably a better way to do it. The reason why the Pythagorean theorem isn't the best option here, and I'm not saying it wouldn't ever work, but we have a triangle here. We have a smaller triangle, and the information we're given are this length, this man's height is 6, and this length is 16. And if you're dealing with the Pythagorean theorem, it's usually not between two triangles, it's usually within one triangle, right? And so in this problem, we're trying to find out how fast the tip of the shadow is changing. And so they included a couple important variables here. Z is the distance the man is from the light post, Y is the length of the shadow, and X is that whole length from the light post to the edge of the shadow. Similar triangles, and therefore a ratio between the triangles is the best option here, okay? If they're asking us to find the rate at which the tip of the shadow is changing, do we all agree that's dx dt? It's not dy dt. What is dy dt finding? Let's interpret this. And then I'll get your question, Wendy. What's the y dt finding, Cole?
How quickly the man's shadow is shortening.
Yes, what the rate at which the shadow length is shortening. But how did they word it? The rate that the tip of the shadow is changing has to do with this x length. Do you get that? Okay. That's where the tip of the shadow is relative to the light post. Okay? Wendy.
Can you not assume that it's a 3, 4, 5 triangle and like make it a 12, 16, 20 and then use Pythagorean theorem?
Can I ask you where you're getting the 3, 4, 5 from?
I don't know. I just thought because 16 is like you can multiply 4 by 4 and then you could just multiply that.
Now, were we told the length of the shadow and the time in question was 12?
No.
Okay, then we can't assume it's a 3, 4, 5. Cool.
I used a different strategy where I took the light, the tip of the man's head, and then the 16 foot, and I made it a triangle that had a height of 10. And then
Hold on. You took, say it again.
The light, the tip of the man's head, and then the edge of the light post. Yeah.
And here?
No, straight across.
Here.
Parallel to the face.
Okay.
Yeah. And then I made a ratio that was 10 over the rate he was moving, 5, and then used it as 6 over the rate the shadow was moving.
Okay.
I added that to the 5, got 8.
Yeah, that would be fine too. For those who had no idea where to start, let's do it this way. Okay? We're going to do it the way this is set up. All right. So at this point in time, you need to ask yourself, what am I trying to solve for and what am I given? And that's going to help me decide which ratio to set up, okay? Obviously, we're going to use the 16 and 6. Do we all agree with that? Okay. Anytime you can use some numbers to set it up, that's best. And you have to ask yourself, am I allowed to use those numbers in the original setup? Yes. So, listen, big idea. There's sometimes you're allowed to use the original numbers in the setup. There's sometimes you're not allowed to put numbers in until you've taken the derivative with respect to time. When is the distinction there? What is the distinction? When the numbers you're given aren't changing. They are constant, right? Is 6 constant in our problem? Is the man's height? Yes. Is the height of the lamppost constant? Yeah, so we're allowed to use those. Okay? And to kind of flash back to yesterday's problem, I don't want to confuse you. And I didn't want to do this at the time. But in this problem here, when we went to do sine of theta is y over L, could we have gotten by with sine of theta equals y over 10? And then taken the derivative? Because what I just said, listen carefully, what I just said was, in the shadow problem, if there is a number that is not changing in the picture, you can use it at the beginning. Okay, that means for this problem, the length of the ladder was not changing. Mr. Westphal is saying I can use that in the beginning of the picture. Cool.
You could use that in inverse sign, but not as it's represented because that would make an indefinite fraction.
Let's see. Okay, what's the derivative of sine of theta with respect to t? Cosine theta d theta dt. Awesome, thank you. All right, low d high 10 dy dt minus high, what's d low? Over, oh my gosh, I'm not even thinking straight now. This is just ridiculous. All right, cosine theta d theta dt low d high dy dt minus y times d low is 0 all over 100. Are you with me? Cosine of theta at this time in question was 8/10. This is 1/10 dy dt. Multiply by 10/8, what do you get? Oops, sorry. Dy dt, were we told -2 in that problem? Were we told dy dt was -2? Okay. So multiply by 10/8. What's -2/8? Does it work in that problem? Yeah. Because the number we plugged in is a constant in that problem. It's never changing. Now, I'm not trying to confuse you, but I'm trying to use this example as there's some things in the picture that are only applicable at the time the picture is taken. There's some values that are constant throughout the problem. Those you can use in the problem if it makes it easier for you. So go back to this one. Because of that, we can use the 6 and the 16. All right. So here we go. 6 over y. Remember setting up proportions in math, right? Name it. Algebra 1, 8th grade math, probably 7th grade math. Man's height over man's shadow equals lampost's height over total length of man's distance plus shadow, right? 16 over x. Do you agree with me? Am I confusing you right now, or are you guys okay? We okay right now? All right. Then I'm going to give you an alternative. What about 6 over y, keep this part the same, equals 16 over, what if you're like, you know what, I used z, I used y, but I never called the whole thing x. Could you put 16 over z plus y? Because x is z plus y. Could I put 16 over z plus y? Yeah, but what are we trying to solve for? The rate at which z plus y is changing. Do you see how that would be complicated? So at that point, what I'm trying to teach you is, if you set it up that way, predict, am I going to get to where I need to go? And I'm not saying it's not possible. It's just the rate that we're looking for is this tip of the shadow's rate, and it's that whole length from the light post. And that's z plus y. That's not going to give me very easily what I'm looking for. Okay? So decision time. I'm trying to find dx dt. I could take the derivative as it is. Would it probably make it easier to solve for x first? I bet most of you would be more comfortable with that. If not, that's fine. You'd still have to do, you're going to do a quotient rule over here, or recognize that you could bring it up as x to the -1 if you really wanted to. But when you do that, you're going to get your dx dt, and you just have to solve for it. If you prefer to cross multiply first and get 6x equals 16y, divide by 6. What's 16/6? 8/3, right? X equals 8/3 y. Related rates, derivative with respect to time. All right, dx dt. Constant multiple rule. 8/3 goes along for the ride. What's the derivative of y? dy dt. Do we know dy dt? Because we have to find dx dt. How did they word it? A man walks at a rate of 5 feet per second. Would you get that's dy dt? Yeah, that would be dz dt. A man walks at a rate of 5 feet. That would be this one. So we'd have to find dy dt at that instant, wouldn't we? Or write this as a function of, it's probably be easier. They gave us dz dt. Do you agree to find that? We're going to have to know what dy dt is. All right, how do you find dy dt? he said, what rate is it for shadow change? Did I even write that for you?
Oh, it's on the back.
Did it say it in the answers? Must do B first. So how would we find dy dt? Did I say it in class? Oh, I said the answers were on there, but I think I forgot to say to do part B on that one first. At what rate is the length of his shadow changing when he is 10 feet from the base of the light? How's that going to help us? Yeah, that'll give us z at that time in question, won't it? Okay. And that one you do have to find, let's see, let me read it again. At what rate is the length of his shadow changing? So that's your dy dt, isn't it? Because his rate is dz dt. Watch up here. How fast is the length of his shadow changing would be your dy dt. So that's why you have to do that part first. All right, 6 over y equals 16 over y plus z. Why wouldn't you, I'm trying to help you guys see through this. Why is it here we're going to do 6 over y equals 16 over y plus z and not use x in that problem? We're trying to find dy dt, right? And then you could cross multiply if you wanted to. You're going to get 6y plus 6z equals 16y. 10y equals 6z. You want your dy dt, so solve for y, take the derivative. We get negative 3 feet per second for dy dt. So up here, third times negative 3 is negative 8 feet per second. That's part A. Part B, the length of the shadow is decreasing by 3 feet per second. So honestly, I forgot that 9b did not say that, or 9 did not say to find b first. I knew it was somewhere. I forgot it was on the answers. It says must do b first. I apologize for that. That one's kind of tricky. If you want to do another one like that, I think there was one, like number 4, I think it was. If you'd like to try another one of those. Might even be another one. Number 21 is similar to that one. If you want to practice some more of those. Any other questions from the worksheet? How about number 20? How was 20? You all right? Anyone want to see anything worked out on number 20? All right. So here's where we're heading in the next little bit. We've got, I wasn't sure how many questions you guys would have on 4-6. Tomorrow, we're going to review 4-5 and 4-6. It's looking like a quick quiz on Monday over 4-5 and 4-6, and I will narrow it down. So when I say review, it's like kind of like a quiz review, but we're also going to do. I'm going to introduce an activity you guys are going to be doing. I will narrow down the related rates question types that would be on the quiz. All right. The linearization, you're going to need your calculator. So this is going to be a completely calculator allowed quiz on Monday. All right. The thing about related rates is that the way they do it in traditional textbooks, did it log me out? Shoot. The way they do it in traditional textbooks and the way they do it on AP Classrooms is a little different. I did not assign you guys anything. What we're going to do right now is you can just watch up here. I'm going to put the questions up on the board. I had them ready. They're not ready anymore. I'm going to put the questions up on the board, and we'll kind of look at what might the AP test writers, how might they ask these types of questions, okay? It's interesting where they tuck this away. They put this back in, if you ever want to watch videos on this stuff, feel free to. There they are. They tuck it in Unit 4 on AP Classrooms. And there were some multiple choice. Can you guys read that? That's pretty good. Wow. All right, let x and y be functions of time t such that the sum of x and y is constant. Which of the following equations describes the relationship between the rate of change of x with respect to time and the rate of change of y with respect to time? So take a minute, solve it, we'll vote, we'll go over it, we'll move on to another one. I think they have an answer. Who needs more time? Okay. How would you write that expression? The sum of x and y is constant. If they're calling the constant, did they call it anything? Okay. The sum of x and y is constant. How would you write that as an expression, an equation? X plus y equals. Okay, sure. Or C. I don't know. Which of the following equations describes the relationship between the rate of change of x with respect to time? Okay, well, how do I find the rate of change of x with respect to time? The x dt. Oh, I forgot to ask you guys. Who voted on letter A? Who voted on letter B? C? D? E? Good answer. Okay. What's the derivative of y with respect to t? What's the derivative of k with respect to t? 0. I don't see that. But if I add, subtract. subtract dy dt, I get b. Does that make sense? Okay? Bless you. Please, please, please train yourself to take what they're saying in words and write an expression out of it. One of the biggest habits I see students make is they'll read it and they'll be like, it's one of those. I'll just narrow it down. Like not even writing anything down. Okay? Let's just be honest. When you see multiple choice, in your mind, it's like a challenge. How little can I actually write here? Okay? You know who you are. Am I right? Am I right? What? I saw a bunch of other ones.
Hey, let's go. Wait, that.
I know this one.
It's me.
We'll probably hold off on that one.
I like number 2 better.
I don't know. We're making pizza dough into a cylinder. That's realistic. Avery, how's that sound? Huh.
Yeah, why?
Making some dough. There we go. There we go. Ooh, Boyle's Law. You guys know about Boyle's Law, right?
Whoa, let's calm down. I just got out of chemistry, man.
Write something down. Write it down. Like, what kind of voice do you want?
British accent.
I can't do that.
Australian?
Can't do that. Can't do that. Okay, I can do that.
What can you do?
No, I can't really. It was just a teaser. Boyle's Law states that if the temperature of an ideal gas is held constant, then the pressure P of the gas and its volume V satisfies the relationship P equals K over V, where K is constant. I love that you guys are doing that now. I would just love to like pop into a college calc class if you have to take it again, or Calc 2, even better, and just hear the professor ask a question. You're like, All right. Which of the following best describes the relationship between the rate of change with respect to time of the pressure and the rate of change with respect to time of the volume? In other words, find the derivative with respect to time. And K is constant. What rule is appropriate to take the derivative of P equals K over V with respect to time? What rule is appropriate on the right side? Quotient rule. All right, take a minute, try to solve it.
Oh, you definitely do. It's D. It's my final answer. It's D.
It's 0. That's null.
Yeah, I don't know where to jump on the trail. Dude, what?
All right.
Yeah.
Watch him here. If you do low, V. D high, 0. Minus high, K. D low, dv dt over V squared. Then you look to see which one it matches with. Looks like letter D. Yeah. Let's check our answer. I haven't done these yet. Yay! Stop it! You guys are like reinforcing bad habits.
Yeah, if it has more than like 2 lines.
It looks actually
Yeah,
right
I
to me.
just think it's like, yeah, it's
It's either A or B.
It's
We
definitely not.
haven't had an A or B yet. It's gotta be A or B.
Bad habits will work. Is it bad habits will work?
Surely B. No.
work every time.
Oh, yeah.
If it becomes a habit, you become good at it. Guess B. Guess B.
Can you read it in different
Yeah, in Spanish.
We didn't see which one to guess on.
Derecho. Isn't it right? Derecho.
I've been in Spanish.
Izquierda. Derecho.
Sounds right.
That's Spanish?
Yeah.
I'll take German. I'm sticking with my first guess.
All right, a right triangle has a base x feet and a height h feet, where x is constant, and h changes with respect to time t, measured in seconds. The angle theta, measured in radians, is defined by the tangent of theta equals h over x, which of the following best describes the relationship between d theta dt, the rate of change of theta with respect to time, and dh dt, the rate of change of h with respect to time. Please just stop. Draw this out. Write it out. After chapter 4, we're gonna spend a week on AP review. Like we're actually gonna. That's why in my head. We're gonna spend a week where we actually go through a practice test. All right. So get in the habit. Write these down. I got to draw a triangle. What'd you say?
It doesn't say which angle's bigger.
Wait, which angle is this?
Like, which one am I trying?
Okay, they're telling you that tangent of theta is h over x.
Oh.
You know it's not
Tangent of theta is h over x. Opposite over hypotenuse. Opposite over adjacent.
Whoa.
Please excuse.
My dear out.
No, I mean on this.
I can draw it.
I just have us draw. I'll see what it is.
Ooh, I just got an email. What's new for your school at Cedar Point?
Oh. We got it.
We could do so much
Exclusive
calculus.
school days on May 5th and 6th.
We should
Go
try.
take
That
pictures
should
of
be
roller
okay.
coasters.
Assembly open for school groups and resort guests.
I think we should go.
Running as part of our physics, science, and math.
Yeah.
We can calculate the speed of the extra.
See you, Mom.
It's I love
Now let's go.
We can do it after. Perfect.
Yeah, we'll take a picture.
But we have to find the break.
Yeah, that's right.
Like, how much does it slow down as it comes to you?
I haven't done this one yet.
At the instant of being at the very top.
I actually don't know.
Do you agree that that's the correct setup for this triangle?
So easy.
Again, I haven't done it, so this is kind of fun because I'm going to walk through how I'm thinking about it. Tell me what you guys think. Okay? Here are the two options. Do you all agree? To get a d theta dt, which all the answers are asking us to find. Okay. I'm going to have to take the derivative of this thing. Option 1, take it as is. But what's the derivative of tangent of theta? Secant squared theta times d theta dt, right? Option 2, get theta by itself first before I take the derivative. How do I get theta by itself? I have to get rid of the tangent. What gets rid of a tangent? Tangent inverse. I'm not saying this is the best way. I'm just showing you what both ways would get you. That way would get you theta equals tangent inverse of h over x. No calculus has been done on this problem yet. This is one option. D theta dt equals, what's the derivative of this thing? 1 over 1 plus u squared times that, where x was constant. Yes? Where x is constant. Which way do you think is better? Secant squared theta, d theta dt equals this thing? And I'm not going to do the quotient rule on this. Why am I not going to do the quotient rule on this? Because x is constant. Remember if it was like x over 5? Would you do the quotient rule on x over 5? No. What's the derivative of x over 5? Wouldn't you just write this as 1/5 x and then dy dx? Is 1/5? Guys, this is way back. This is easy. This is an easy power rule. Oh, that's you. Okay, let's make it a little easier. Wouldn't this be 2 times 1/5 x? Or 2 times x over 5? Because this was x squared over 5. Couldn't I take the derivative of that? And the 5 just stays down in the denominator because it's a constant multiple? Right? X is constant here. X is a constant. What's the derivative of h over x with respect to t? Isn't this 1 over x times h? Isn't this 1 over x times h? So isn't it going to be 1 over x times the derivative of h? dh dt. 1 over x dh dt. Yes? This is painful.
So
I'm gonna have you guys finish this up for homework.
Oh.
You think it's D? Think it's A?
Yeah, facts.
I believe him.
Yeah, I agree. It's a lazy.
All right. In all honesty, we're gonna do a couple problems for homework. You're gonna finish this one. I want you to have reasons. All right. Also, I'll tell you what. I'm gonna let you pick 3 from the worksheet you did not do last night. Pick 3 that you think would be helpful for you. Check them on the back. You have to have 3 completed that would be helpful for you. Okay, there's a lot of variety in here. There's repeats, which is good. Because you can say, oh, I missed that problem last night. I should probably do another one like that. But there's enough variety that you should be able to pick 3 that would be helpful. Got it? And I want them to be beneficial for you. So pick the ones you think you would need. Maybe another shady problem. A little shadow. Okay?
I'm like right there. I'll give up.